Okay, in this tutorial we're going to look at the balancing of chemical equations. So when balancing chemical equations is simply a process of making the number of each type of atom equal on both sides. So it's a process of making the number of atoms equal to both sides. What does this mean? For instance, given a chemical equation, let's say A plus, forgive my handwriting, given an equation of A plus B resulting to C plus D. So the number of atoms to the left should equal to the number of atoms to the right. So this is simply balancing of chemical equations. Okay. Another take that you have to know is that when balancing chemical equation, you have to make sure that you never change the chemical formula of the compound when balancing chemical equations. For instance, given a compound of H2O, which is a common water, so when we have this, you do not have to change the chemical formula, but you can change the number of atoms. For instance, water has got 2 atoms of hydrogen. So you always have to include a number in front this side. You include a number only in front. You only include the number only in front, but don't change this. Also don't include the number, the suffix down here. No. So you only put the coefficient and not the suffix. So never change the suffix, but change the coefficient. So you can change the coefficient, but don't change the suffix. In this case, the suffix 2, it's H2O. So if you put a 4 here, this one it's a coefficient, and this one, this 2 here, it's a suffix. So never change the suffix, but you can change the coefficient. Okay, this is why we're saying we can change the number of atoms and not the number of, and not changing the chemical formula. Okay, so let's look at some examples. Let's look at some examples, then we can see how we can do. So a chemical reaction was given to be A plus B having the product of C plus D. So these are the reactants, and they are the products. So the left should equal to the right. Okay, so the right should equal to the left and vice versa. Okay, and vice versa. So what do we do? In this case, we are going to have some questions. So question 1. We've got a compound H2, which is the hydrogen gaseous form, which was reacted with chlorine gas, giving us hydrochloric acid in gaseous form. So here, when answering our question, we always have to see the number of atoms. So in this case, this is a product, or this is a reactant, and this is a product. So we've got 2 hydrogens to the reactants and 1 hydrogen on the products. So what do we do? So if here we've got 2 hydrogens and we've got 1 hydrogen on the product, so we put a 2 here. We put a 2 here since we've got 2 hydrogens on the reactants. We move to chlorine. We've got 2 chlorine atoms here on the reactants. This is a product, and we've got, oh sorry, these are products. These are products, and you've got only 1 chlorine. It's like this. We only have 1 chlorine and 1 hydrogen. In this case, we've put a 2 since here for the reactants we had 2 atoms of hydrogen. So here we've put a 2, it's balanced. So we go to chlorine. Chlorine has got 2 atoms to the reactants, and so we check for the products. The products for chlorine has got 1. So these 2 is for both hydrogen and chlorine. So these 2 is scattering for hydrogen and chlorine. So in this case, it is balanced. I hope you understood. So this question is balanced like this: 2 hydrogen, 2 hydrogen. This 2 is for chlorine as well, so 2 chlorine, here 2 chlorine. Okay, so that's a balanced equation. So let's look at another equation. Question 2. So look at sodium, which is in aqueous form, reacting it with hydrochloric acid in aqueous, giving us sodium chloride plus, okay, sorry for the space, just try to minimize my words, or rather my compounds. Okay, so we have sodium, it is in aqueous chlorine, giving us sodium chloride and water. Okay, listed symbols here, it's aqueous, even here it's aqueous, this is aqueous, this is liquid. So always when balancing equations like this, you have to balance the oxygen first, then hydrogen, then you balance other compounds. So first you balance with the compound, you balance the atom oxygen, or rather the compound. If you see any compounds having oxygen, you look for the element oxygen in the compound and balance it first. Then you go to hydrogen, then you can focus on other elements. So let's move in that direction. So we've got oxygen here. So for the reactants, oxygen is 1. For the product, it's 1. So this means oxygen is balanced. We go to hydrogen. Hydrogen is one here. If there is another one here, so we've got two hydrogens. What for the products? We've got two hydrogen. So hydrogen is balanced. Let's move to sodium. We've got one sodium here, and we've got one sodium here for the product. So even sodium is balanced. Let's move to chlorine. We've got one chlorine here, even here is chlorine. It's just one. So this equation is balanced as it was. Okay. Let's look at another question. Hope it's clear. Okay. We've got this one in solid form. Got oxygen gas given us this compound here in solid form. So let's use a 5. So we've got one here. This is just one. Even this side it's 2. So for us to have a 2, since we have a 1 here, what do? So we don't start with this, since the instructions we have is that if there is oxygen in the equation, balance oxygen, then hydrogen. After you balance these two, then you look for another element. Now in this case we only have oxygen and no hydrogen, so let's balance oxygen, then we move to other elements. So oxygen, we have 2 oxygen for the reactants. The reactants are having 2 oxygen. Let's go for the products. The products, we have 5 oxygen. So what do? We look for a number whereby when we multiply it with 5, we look for a number to balance these 2 hydrogen. So if we have a 2 here, simply just put a 2 here, so that when you do 5, you multiply it with 2, you multiply it with 5 to give you 10. So even this side, for you to balance the oxygen, just look for a number that you can put here, so that when you multiply it with these 2, it will give you 10 for you to balance the reactants and the products. So just simply put a 5 here. So when you do 5, you multiply it with 2, you have 10 oxygen. Even here 2, you multiply it with 5, you have 10 oxygen. Then you balance the other element. In this case we've got this one. So this one we are having 2, multiply it with 2 to give you 4. So just simply put a 4 here and the equation is balanced. Okay, hope that is done. Hope we can see what's happening here and we are okay with the equation. Let's move to another equation. Balance oxygen first, then move to hydrogen, then balance any other element. Okay, I guess this is the third equation we are solving. Our third equation is like this. Reacting it with oxygen gas, having that plus that. So let's balance oxygen. Oxygen, we have 2 here. This side you've got 2, and this one which is 3. Okay, interesting. So let's balance oxygen first. So if we put a 2 here, then this simply means this 2 is for hydrogen and oxygen. So this oxygen 2 plus this 2 to give me 4 for the products. What of for the reactants? So for the reactants, since I've got 2 here, I'll just put another 2 here for me to do 2 by 2, which will give me 4. So I've balanced my oxygen. 4 here, in the other side is 4. Let me go to hydrogen. Hydrogen, I've got 4 here. 2 by 2 is 4. How about this side? It's just 2. So I'll just put the 2 here. So hydrogen is balanced. Let me look for sulfur. Sulfur, we've got 2 here. 2 here for sulfur. This side, I just have 1. So if I put a 2 here, okay, if I put a 2 here, I'll find out that the oxygen will be affected. Quite right, sulfur is balanced, but the oxygen is affected. What do I do? So the oxygen, I have 4 plus 2, which is 6 for the 6 oxygen for the products. So how do I balance here? Here I've got 4. So simply eliminate this one. And put a 3. So that I've got 6 oxygen and the equation is balanced. You can check. Equation is balanced. Okay. Let's answer 2 more. We answer 2 more, then we'll be set. Balance oxygen, then hydrogen, then go for any other elements. So the element that I'm having here is calcium carbonate, giving us calcium oxide plus calcium plus carbon dioxide. So let me balance oxygen, then hydrogen. In this case I don't have hydrogen, so I'm not concentrating on hydrogen, so just oxygen, then any other element. So I've got 3 oxygen here, even here it's 2, 3. 1 calcium here, even here it's 1. So the equation is balanced because I've got here 1 here, even here it's 1, even here it's 1. But even if I don't include them, it's just the same. Okay. Let's look for another equation. The last one, but not the least. We have iron, chlorine gas, is a solid, state symbols. Make sure you don't forget to include state symbols. Make sure you include them. Here we've got it is in solid form. So here you balance oxygen, then hydrogen, then any other element. Now in this case we've got we don't have oxygen and hydrogen, so we'll just balance the elements that we have. So we can start with iron or chlorine. You can start with iron or chlorine. So iron here it's 1, here it's 1. Chlorine here it's 2, here it's 3. So what do I do? What if I put a 2 here? So the chlorine here will become 6. And since it's 6, I'll put a 3 here. Chlorine here it's 6, even this side it's 6, because 2 by 3 it's 6, and 3 by 2 it's 6. Iron here it's 2, so I'll put a 2 here, then I'm done. Thank you very much. Thank you very much. This was M Lumai Learning Institute. Like and subscribe to our channel. Goodbye. Thank you very much.